All right, this is a video on section 9.2, which is an introduction to a matrix. The plural form of that is matrices. First thing is that a matrix is a rectangular array of numbers. If you'll look down below, you'll notice that this is a matrix. It's a rectangular array of numbers, as well as this one. And then not only that, every single number that's in a matrix is called an element of the matrix. So again, if you're looking at these two examples here, I have quite a few elements. Each one of these is an element of my matrix. An augmented matrix is a way to write a system of equations in a matrix format. And so you'll notice here, part A of this first extra example, this is a system of equations, and we can take any system of equations and rewrite it as a matrix. And not only that, it's actually going to help us to solve it. So this is a system that can be rewritten as an augmented matrix, which we'll do in just a moment. And then lastly, in this little bit of an intro here, is that the dimension of a matrix, or the order of a matrix, the size of a matrix, is going to be the number of rows by the number of columns. All right, so let's just go ahead and first of all practice writing a system of equations as an augmented matrix. All right, so the first thing is that every single position, every single element has to be filled. You can't have any blank spots. If there's no number to fill in, then you're just going to fill in with a 0. My first column, if you'll notice, all of these are going to be X's. My next column is all going to be Y's. My third column will all be Z's. And my last column will be constant numbers. And then lastly, since my first column is all X's, I don't actually need to write that they are X's. I'm only going to use the coefficients there. So for my first row, which we normally work through the rows first. So my first row is 4, -2, 3, 4. There is a bar there, which the whole bar will be uncovered here in just a moment. But the bar is in place of my equal signs. My next row is going to be 3, 5, 1, 7, and my last row 5, -1, 4, and 7. And once again, you can see that bar there that it shows the equal signs. All right, another example of this. And then this one, I'm going to start with the third row just because it's a little simpler. And so notice that we have an X. So this is going to be 1. All right, and then I have no Y's, so my Y's are going to become 0. And then I do have a Z, which is -3, and I also have a 6 there. So my third row will be 1, 0, -3, and 6. My second row, if I'm working upwards from there, is going to be 0, 1, 2, 2. And my very first row will be 1, 0, 0, 6, since there's no Y's and there's no Z's. All right, now let's go backwards. So this time I'm given an augmented matrix. Let's go backwards and write it as a system of equations. So remember that my first column is X's, second column Y's, third column Z's, and the last column is going to be my constants. So writing an equation then, X minus 3Y plus 2Z is equal to 1. My second equation, 2X plus Y plus Z is equal to 2. And then my third equation, 5x minus 6y plus z is equal to 2. Another example of this, where I have a lot of zeros and ones here, but my first equation is simply going to be x equals 4. My second equation is going to be y equals 2. And my third equation is going to be z equals -3. Now you'll notice all of a sudden my system of equations was completely solved for me just by writing down what the equations were. I have my 3 solutions to this system of equations. When you notice, and I'll point this out here in just a moment, but notice that I have 1s on the diagonal and then 0s are everywhere else. This is what's called reduced row echelon form, which is what we're going to talk about next. So reduced row echelon form is where I have all 1s on the diagonals, all 0s above and below the diagonal, and these constants then end up being my solution to the system of equations. And as we just saw in this last example, if I have reduced row echelon form, the solution just jumps right out at me. So before I talk about how to get reduced row echelon form, I need to teach you how to enter into the calculator. Now, basically, I have instructions written out here, so I'm not going to go through this in the video per se. So what I would do if I were you is I would just simply pause the video. And the first matrix that we want to enter into the calculator is this matrix right here. And so if I were you, I would pause the video and just simply go through steps 1 through 5. All right, so hopefully you've had a chance then to enter your matrix into the calculator. And now what we're going to do the same thing over again, only this time you're not just going to enter a matrix into the calculator, you're going to use reduced row echelon form in the calculator to solve a matrix or to solve a system of equations. So once again, I'm going to let you pause the video. What you want to do is use example 1. So that's down here at the bottom of the page. Use example 1 and work through steps 1 through 5 that you see right here to be able to solve the system of equations by using RREF in your calculator. All right, so hopefully you've had a chance then to work through the calculator on this, and I'm just going to show you the work that can be shown on this. So for this example, the first thing that we want to do is, I'm sorry, that just skipped there. The first thing that we want to do is to write our system as an augmented matrix. And then the second thing that we're going to do is we're going to go ahead and put this into the calculator and use reduced row echelon form to get a new matrix out, an RREF matrix. Once I have my new RREF matrix, I can see that my two equations are x equals -4 and y equals 5. And this ends up being my solution. All right, for example number 2, this is going to be the very first time that we've ever tried to solve a 3-equation system. So we've done a lot of two solution systems, 2 equation systems back in section 9.1. This is our first 3-equation system or 3-solution system. But the nice thing is when we have reduced row echelon form, this is quite simple to do in the calculator. All right, so the first thing that you'll do is go ahead and get yourself an augmented matrix. Then you're going to take that augmented matrix and follow the steps that we just went through here in the calculator, or hopefully that you followed through in the calculator, to turn that into an RREF matrix. And once I have that RREF matrix, then I can see that my solution is going to be 3, -1, -2. And yes, it is legitimate to have 3 pieces of a coordinate. The next example works the exact same way, so turn it into an augmented matrix. Use your calculator to find the RREF. And once you have the RREF, your constants are going to be your final solution, -3, 0, 1. All right, so then what does it look like if I have an inconsistent system or a system that has infinitely many solutions and I'm trying to use RREF? So what does this look like? So usually your directions will just simply say use RREF to solve. So what we're going to do here is we're going to go the same route that we have been going. So we'll get ourselves an augmented matrix. We'll put it into the calculator to get the RREF. And all of a sudden, something happens here that's weird. This last line says that 0 equals 1. And we know good and well that 0 can never equal 1. So this is our clue that says, hey, this is never going to be true. And so you are not going to have any solutions because the lines are parallel to each other. These lines will never touch each other. And so there are no solutions, or the null set would be your final answer there. If you have a system that has infinitely many solutions, again, you might only have the directions that just say use RREF to solve. And so we'll go about this the same way that we did with the other ones. So first thing is we'll get our augmented matrix. We'll throw it into the calculator to get RREF. And when I look at this, there's an issue because it doesn't quite make it to the RREF form. So what I did was I went ahead and I took the first row and changed it into an equation, took the second row and changed it into an equation as well. And I noticed, okay, I'm never going to be able to solve this. And here's the trick. If you have two unknowns, you need two equations to solve. If you have three unknowns, you need three equations to solve. If you have 9 unknowns, you need to have 9 equations to solve. Unfortunately, I've got 3 unknowns, but I only have 2 equations. So this was my first clue that somehow I'm going to have a hard time getting some solutions here. So what we're going to do is for this first equation, I'm going to isolate the x. And for the second equation, I'm going to isolate the y. And so this is what I get when I isolate x and y. And then my solution is going to be for the place of x, notice that I put what x was equal to. For the place of y, I put what y was equal to. And then for z, I just left it as z because I had no way of getting an equation for z.